Welcome to this video that describes a new type of lens. Ingenious, small and efficient as modern cell phone cameras are, they are still large compared to the slim phone in which they reside. The largest component of these cameras is, of course, the lens. Traditional lenses, as are still used in the camera, have the same problems as they always have had. However, we have to acknowledge, though, that improved materials have reduced those problems. One such problem with modern lenses is as shown in this diagram. Here, light enters a convex lens. It undergoes two refractions, but as you can see, the light on exiting the lens is dispersed. This typically is what we call an aberration. What if we could improve matters further by using some method other than lenses and mirrors? Well, this video describes such a technique. Before considering that technique, though, we need to consider the underlying physics. In this image, you can see a greatly simplified version of something called a metamaterial, or it's sometimes called also a metamaterial surface. A metamaterial surface is made up of an array of nanostructures deposited on a suitable base material. As light passes through these structures, it was found that the light's attributes were altered. It therefore follows that to achieve a particular state of those attributes, a suitable metamaterial surface could be designed. That leads us on to the new type of lens. This lens, as shown in the diagram, is an ultra-thin folded metamaterial lens. It consists of four metamaterial surfaces. The first surface guides light into the glass body, but note I haven't marked the glass body on this diagram in order to avoid congested text. The particular design shown in this diagram is for light of 852 nanometers in wavelength. After the light has entered through the first metamaterial, it's reflected from the gold base layer up to a second metamaterial surface, back to the gold, then back up to the third metamaterial surface, back to the gold, then up to a fourth metamaterial surface, which focuses the light. The light then exits to a normal image sensor. The thickness of this lens from the entrance aperture to the image sensor is just 0.7 millimeters. This folded lens design was developed by Kim et al., and their paper can be found in the link below this video. The size of the nanostructures that they fabricated to get this lens are a mere 750 nanometers. Thank you for watching this video on what can only be called an ingenious lens design.